We are starting our journey with logarithms. So all of these say log, that is short for logarithm. Your base is the itty bitty number that's written below. It's like a superscript, which would be an exponent, but it's below, so it's called a subscript. The stuff in parentheses is called the argument. And then we're going to have something that it's equal to. So all we're going to do in this first set of examples is practice bouncing back and forth between logarithmic notation, and then in a second we're going to go from logarithmic to exponential, and then in a second we're going to go from exponential to logarithmic. So we're going to go back and forth just so you can see what the effect is. So you're not solving for anything, all you're doing is rewriting. And also remember that exponentials and logarithmics are inverses of one another. Exponentials and logarithmics are inverses of one another. So what I have first is your little subscript. This is your base. And I'm going to do a little backward circle thing, okay? So I have the base raised to this power will equal the argument, okay? So how do I write this in exponential? I'm going to have 5 to the second power is 25. I'm not going to simplify anything. I'm just practicing writing the notation. So this is exponential notation. This is logarithmic notation. So you'll notice that the answer to this logarithm was the exponent that makes this true. Okay? And your base was the same. This is log base 5 of 25 is 2. So your bases are the same. So let's look at this one. Oh no, there's not a base. If your base is not written, it's one of two things. It's either 10 or it's E. And I'll show you E in a second. Okay, but right now it's not written. So kind of like we say that the square root of 2, or sorry, the square root of something is 4, and it's implied that I'm taking a square root. It's implied that this is base 10. So again, I'm going to do a backward circle. My base raised to this power will equal that number. Okay, so I am taking the inverse of a logarithm. So the way I read this is the log base 10, or in this case, I would say the common log. So a base 10 logarithm is called a common log. So I could say the common log of 1,000 is 3. Or I could say the log base 10 of 1,000 is 3. So 10 raised to the third power is going to give me 1,000. And you should recognize that that is true. Okay? So the answer to a logarithm is the exponent that makes this true. Okay? So now what do we have? I've got log base y of x equals 2. So I'm going to do my little backward circle thing. And I'm going to say my base is y. My exponent is 2, and that should give me x. So y raised to the second power will equal x. Okay, y to the second power will equal x. So again, the answer to a logarithm is the exponent that makes this true. So this one, my base is not written. It is implied to be 10. So again, this is a common log. So I would read this as log base y of x is 2. This one I can say the common log of x is 3. Or I can say the log base 10 of x is 3. But I'm going to do my backward circle. So I've got 10 raised to the third power is going to give me that answer. We're not simplifying. We're not answering. Okay, so hopefully you would recognize that that would be 1,000. But I don't want that. We're just practicing converting between the notations. So leave this alone. Okay, now I've got an ln. What on God's green earth does that mean? Okay, if I have an ln, that means the natural log. So I would read this as the natural log. Okay, and its base is e. So it's not nl. We got this from the French, and they put their adjectives after. So it would be ln. Sorry, stupid dog. Okay, so it would be ln and it's implied that it is a logarithm in base e. Okay? And so this is the other time that you're not going to write the base. So ln immediately screams, my base is e, and it's a natural log. So common logs are base 10. Natural logs are base e. And so instead of writing log base e, we just say it's the natural log. So you're still in log world. It's still a logarithm, but we're just practicing. So it's implied that your base is e. And I'm going to do my backward circle. So I'm going to take e to the third power equals e to the third power. Okay? So looking at that, again, don't simplify anything. We'll say e to the third equals e to the third. So the natural log of e to the third is 3. Okay? Last one, my base is not written. So what is it? It is implied, since it's a natural log, that my base is e. So I would read that as the natural log of x is 5. So again, notice that this is the exponent that you would raise this to get that answer. The answer to a logarithm is the exponent you would raise the original function to. So I'm going to do my backward circle. I've got e to the 5th, and that is going to equal x. So the answer to a logarithm is the exponent that would make this true. Okay, and this is a natural log. So let's try and go backwards. So now I've got exponentials, and I want to change them into logarithms. Okay, so your base will be the same. In either case, your base will be the same. So what I have here is my base is 3. So in log world, my base will be 3. Okay? The answer is the argument. So the answer is the argument. Notice the A sound. So the answer is 9. That's my argument. And the exponent is what it equals. So it equals the exponent. Notice the E sound. So A's go together, E's go together. So it equals my exponent. Okay, we are not solving anything. We're just converting. So this is all exponential notation. Now we're going to logarithmic. So in this case, is 3 squared 9? Yes, it is. So this is the inverse of that. And the answer to a logarithm is the exponent that would make it true. Okay, so this one, I'm in base 10. This is a common log, which means I am not going to write my base. Okay, my base is 10. That's one of the bases, one of the two bases I don't write. So I will say the base is 10. I'm not going to write it. The argument is the answer. So the argument is the answer, or the answer is the argument, and it equals the exponent. So it equals the exponent. So again, 10 squared is 100? Absolutely. This is a weird way to write 2. Okay, so as a math person, if I see log 100, oh, that's 2. Okay, it's an equivalent expression. What is my base? My base is x. So this is not a common log. I will say log base x. The answer is my argument. The answer is my argument, and it equals the exponent. Equals the exponent. Okay, what do I have here? This is a common log. My base is 10. So I will not write the base. It is understood to be 10. Okay, so I have log base 10 that I'm too lazy to write. Okay, the argument is the answer, and it equals the exponent. Equals the exponent. Okay, again, the answer to a logarithm is the exponent that makes this true. Okay, so we're still just practicing, converting back and forth. Now I've got 2 to the x equals y. This is exponential. What is my base? My base is 2. My base will be 2 over here as well. So I have log base 2. Again, it's a little subscript. It's low and underneath. Okay, the argument is the answer, and it equals the exponent. And the final one is going to be e squared is x. Well, hang on a second. E, I know something about him. E is a natural log. That's the other time that my base is not written. So the natural logarithm is going to be written ln. Okay? So I will have the natural log that immediately tells me I am working in base e. The answer is my argument, and it equals my exponent. It equals my exponent. So just take a look at this for just a second. Natural log of x equaled 2, and then common log of 100 equals 2. These are just weird ways to write 2. Okay, we've got lots of ways to write 2. You can say 8 over 4 is 2. Okay, so there's lots of ways to do that.